Today on In Your Face Anatomy, we are looking at connective tissues, muscle tissues, and nervous tissue. So let's get into it. All right, connective tissues. So last time we talked all about all of our epithelial tissues, making sure we understood squamous, cuboidal, and columnar versus simple and stratified. So today we are looking at all of the different connective tissues. But before we get into connective tissues, we need to understand that they have a little bit more space in between most, and I stress most, connective tissues. Just meaning we have more room in between the individual cells. With our epithelial tissues, we stack them right on top of each other for the most part. With our connective tissues, we got a little bit more wiggle room, a little bit more elbow room. And what that means is we have a little bit more space in between all of these individual cells. Now, we refer to that space as the extracellular matrix, but that's all it means, is the space in between the cells that are in this tissue. So my connective tissue, that's one of its defining characteristics. It's got a lot more ECM, or extracellular matrix. So when we look at the ECM, what we're really seeing is proteins. Our cells are making proteins and they're shipping them out in their vesicles, and it's going to end up in that ECM. And we've got a ground substance. So the ground substance is really just the fluid portion of my extracellular matrix. A lot like the cytosol was the fluid portion for my cytoplasm, my ground substance is the fluid portion for my extracellular matrix. And what it does for us, and that's important, it provides a medium. It allows these cells to start transferring substances back and forth between each other through this ground substance, through this extracellular matrix, so they can make all the exchanges that they need to make. So we have a couple of cell types that we need to make a distinction on. We have three different types of cells that we associate with connective tissue specifically. Our first type of connective tissue cell is a fibroblast. And one of the big things about fibroblasts is they are star-shaped, so that makes them super easy to spot, super easy to distinguish and identify. They are the most common type of cell that we have in connective tissue, and they are fixed cells, which just means they're stuck in place. Wherever they're at, that's where they're at to do all of the things, all of the functions that they need to do. They are fixed cells. Then we have mast cells. That's our second type of cell with connective tissue, mast cells. They are also fixed like our fibroblasts are, but typically we find these guys near blood vessels, specifically arteries or veins, well, more so for arteries. But what I really want you to know about mast cells is they secrete heparin, which is going to work to prevent blood from clotting. So we can move blood and the white blood cells and anything else into an area that we need to, because we can stop the blood from clotting using heparin. And histamine. Histamine, our mast cells release, and we're going to associate histamine with inflammation and allergies. So inflammation is a normal part of your body's processes. It's your body's attempt to stop the spread of microbes, is why we get inflammation. And our third type of connective tissue cells is macrophages. The first thing I want you to know about macrophages is that they have an AKA of histiocytes. Histiocytes, AKA macrophages. These guys start out as white blood cells, so they're phagocytic. They're going to bump into something, they're going to try to reach out, grab it, pull the whole thing in. These are wandering cells, so they are not fixed in place. They can move about the tissues freely. So be able to distinguish fibroblasts, mast cells, and macrophages. And the last thing we need to look at before we get into the actual connective tissues are the connective tissue fibers, the fibers that we're going to find in the various types of connective tissues. So first is our collagenous fibers. These are the thickest of all of our fibers. They are made of collagen, which makes sense. That's why we call them collagenous fibers, because they're made of collagen. They are strong and help hold structures together. We also call these white fibers. We find them in our tendons and our ligaments. Now we call them white fibers because typically the tissue that has collagenous fibers in it also has a poor blood supply. So when we look at it, it has more of a white effect to it instead of that nice pinkish red that our tissue normally has, because we just don't have a lot of vessels in it. So we find this with our tendons and our ligaments. That's why it takes so long to heal when you sprain your ankle, because it's mainly comprised of these collagenous fibers and it's got a bad blood supply going to it. So it takes longer to bring in the fresh tissue, get out the bad tissue. Everything takes longer because it has a poor blood supply. But that's also what makes it strong. We've given up the blood vessels to make room for these extra strong fibers. Our second type of fiber are elastic fibers. These guys are embedded in elastin. So they are elastic, they're stretchy. So this is going to be connective tissue that has a little give and take to it. So we find our elastic fibers in our vocal cords, so we can change pitch with tension on them, and our airway passages. So when we inhale or exhale, we need a little give in our airway passages, so we use our elastic fibers to make that happen. And then lastly is our reticular fibers. Now they're a little tricky. They are thin, and they're also made of collagen. So our collagenous fibers are made of collagen, and our reticular fibers are also made of collagen, but these guys are thin where our collagenous fibers are thick. We find these with supportive networks around the body. Typically, they're going to support internal organ walls with our reticular fibers. Okay, the last thing before we actually get into the individual types of connective tissues is how we categorize our connective tissues. We have two categories. I've got connective tissue proper and connective tissue specialized. So with connective tissue proper, this is all of the types of tissue that you would probably assume are connective tissues. I've got adipose tissue, I've got loose connective tissue, I've got dense connective tissue, I've got reticular connective tissue, and I have elastic connective tissue. Especially for things like loose, dense, and reticular, 100% that's absolutely connective tissue, just helping hold things together. With connective tissue specialized, this is the kind of tissue that you don't really think of as being a connective tissue, but it is. So I've got cartilage in all of its forms, I've got bone, and I've got blood. Blood is also a type of connective tissue. So for this one, let's know what are my connective tissue propers and what are my connective tissue specialized, so we can make that distinction on the test. All right, enough of the preliminary stuff. Let's get into a connective tissue. So our first one up is adipose tissue. So adipose tissue is also known as your fat tissue. These are your fat cells. And in fact, we call the fat cells adipocytes. So adipo means fat, cyte is cell. So these are fat cells. Adipocytes are the cells of adipose tissue. That's what we're binding together to build this tissue. So we function, adipose tissue functions to cushion, to insulate, and to store fats. Cells are adipocytes, we already said that. We find it beneath the skin, behind the eyeball, and then around certain organs like the heart and the kidney. They have a layer of fat to surround them to help insulate them and protect them. Now, the thing about adipose tissue, or adipocytes for that matter, the nucleus often gets pushed off to one side as a cell starts to accumulate more and more fat. That's its job, is to store fat. So it's grabbing all the fat it can and it's pulling it inside of the cell. And in doing so, we start to get so much fat that the nucleus slowly gets pushed farther and farther and farther aside. And that's what we can see here. So I sketched this out, a real quick sample of adipose tissue when we look at it under the microscope. So it would start like this with my individual adipocytes. Then all along the edges, what we're going to have is this flattened, darkened nucleus that gets pushed right up against the side of the cell, where the cell is accumulating more and more of this fat inside of it. So that's what we're really looking for with adipose tissue. We have to look at this. Let me do that in a different color. I just looked at it and saw it. You can't really see it. All right, so there, bam. Make it a little darker. So I don't know that it's dark enough, but you get the idea. We're pushing that nucleus up against the side of the cell. And that's our giveaway that this is adipose tissue. I always say it kind of looks like pink soap bubbles under the microscope because all of this has a light shade of pink behind it. So pink soap bubbles is what I think of. And nucleus pushed right up against the edge, adipose tissue. Then I've got loose connective versus dense connective. So with loose connective tissue, we also call this areolar tissue. So let's know that. The loose connective, aka areolar tissue. And this functions to bind skin to the various structures. We find it beneath most epithelia. Remember, epithelia is your outer layer of skin. So underneath the epithelia, we're going to get loose connective most of the time. And we also find it between muscles. So let's make note, we call this areolar tissue, and especially that it functions to bind skin to various structures. With our dense connective, we're going to bind body parts together, tendons, ligaments, and dermis, and it has a poor blood supply. So this is the tissue that we were talking about earlier when we were talking about white fibers, collagenous fibers being strong and thick, but we call them white fibers because they got a terrible blood supply. So my dense connective tissue has a lot of these collagenous fibers built into it, and that poor blood supply comes along with it. We sacrifice that blood supply for the strength that we want in the cell. So when we look at these tissues, you turn this bad boy a little bit, there we go. What the big difference here with loose connective, because it is loose, we have a lot more space in between the cells. So you can see all of this white kind of shining through in between all of the various fibers and cell types that we have embedded in this cell. We've got lots of white, lots of space. That's how we know this is loose connective, when we can see lots of room in between the structures on the tissue, loose connective. Dense connective is the exact opposite of that. So dense connective, we don't have that same level of space in between the cells. Dense connective, everything is packed in there. We have zero free space. We're cramming it all in there. And a lot of times what we'll get is kind of this segue of purple to a maroony color coming up the bottom. And then the individual cells, we can see my individual cells that are just, the shape varies. They're kind of just all crammed in there as tightly packed as we can, but they all have that nice clean nucleus that we'll be able to see. So loose connective, lots of space, lots of white. Dense connective, no space, no white space shining through. So that's the difference between loose and dense. All right, our next type of connective tissue is reticular connective tissue. Now remember, when we were talking about connective tissue fibers earlier on, we had reticular fibers, and this is when they come into play. We use these to support internal organ walls. So most of the walls of our internal organs now are going to be composed of reticular connective tissue. We find it specifically in organs like the liver, or in the spleen, or in some of our lymphatic organs. The spleen is part of our lymphatic organs, so make that association. So when we draw out reticular connective, it's a little bit different than anything else. Almost everything that we look at in class is going to be shades of pink, just because of the dye they use to stain the tissue. Reticular is not. Reticular is brown, and it's just kind of smudged. I always just think of reticular connective kind of like diarrhea on a slide. That's what it looks like. Nothing else looks like connective or reticular. Nothing. It's just this brown, slimy, bulgy, I don't even know what word I'm trying to make up right now. But there'll be little hits of yellow in there, just because maybe you like corn. I don't know. But there it is. Reticular connective tissue. There's no right or wrong way to draw this. No, there is a wrong way. The way you're doing it is probably wrong. This is the right way to do it. Browns and yellows is what we want, and just kind of smeared everywhere. Elastic connective. So elastic connective, abundant in elastic fibers. That was another type of our connective tissue fiber. We find this between bones and in the walls of arteries, airways, or the heart. Any place where we need a little bit of give with that tissue, we're going to fill it up with elastic connective, just so we have that stretch and pull, especially in things like the walls of large arteries. When your heart pumps, those vessels have to be able to accommodate that surge of blood that is being pumped out of the heart, simultaneously through both ventricles, because both ventricles contract at the same time. Boom! So all that blood gets shot out. So with elastic connective, this is what I think looks like pink brain tissue. And what I mean by that is when we look at this tissue under the slide, what we're going to get is something kind of along this line, where it just kind of looks like brain, like a whole brain in here. And that's just these little folds is just what give it its elasticity to expand and recoil back through these little folds. So that's what we're looking for with elastic connective, something pink and brainy-ish looking. With bone. All right, on to connective tissue specialized now. First up is bone. bone, we absolutely have to know, is also known as osseous tissue. Bone, aka osseous tissue. Supports and protects, nobody's surprised by that. It serves our attachment point for muscles. Muscles have to contract, they need something to attach to, so our bones work. It makes our blood cells. Everyone always forgets that your bones make your blood. Don't forget that. And it has a solid matrix. So the matrix, again, is just the space in between the cells. And that's how we're going to differentiate a lot of our connective tissue specialized. Bone has a solid matrix. And bone is interesting because it's got a central canal in it. So I'm going to draw 3 bone cells here. There's the central canal in my 3 bone cells. And then from that, it kind of looks like a little sun. These fibers just kind of branch out all the way around, tightly packed as we can get them all the way around. And then on the next bone cell, it's going to do the same thing. Let me do it in a different color. And it's where these fibers start to cross each other and tangle about each other that gives bone all of its strength and resilience. So not going all the way around on that one. I really just want to show you how these fibers cross each other. But we kind of get this sunburst pattern. That's what we have to look for with bone. It's kind of fireworks, almost starburst pattern of all of these fibers spreading out around that central canal. That's our central point. There we go. That's better. Cartilage. So cartilage has a rigid matrix. So bone had a solid matrix. Cartilage has a rigid matrix. So just got a little bit of give to it. We have a perichondrion. So that's important. Remember from chapter 1, cond is our root word for cartilage. So when we see cond, that's what we have to immediately think cartilage. So perichondrium, that's just a protective cartilage enclosure around any cartilage structure. Anything made of cartilage is going to have a perichondrium that wraps around it just to help keep it a little bit safer and give it a little bit of extra strength. Again, it has a poor blood supply. We talked about that already with our dense connective, our tendons, our ligaments. We're going to get some of that as well as our cartilage. We just don't leave a lot of room for blood vessels. We sacrifice the blood vessels for the strength. And again, that happens in cartilage. So we have 3 types of cartilage to distinguish. We've got hyaline cartilage, I've got elastic cartilage, and then I've got fibrocartilage. So let's know the 3 types of cartilage. Let's know about the perichondrium, and let's absolutely know about the rigid matrix. So our first type of cartilage is hyaline cartilage. Hyaline cartilage is the most abundant. It is the most common type of cartilage that we're going to find in our bodies. We find it at the end of the bones and in the embryonic skeleton, which is key. I'm going to put a little star next to that, underline it, the embryonic skeleton. So in utero, as we develop, our bones get laid down as little pieces of cartilage that kind of form the model. Then bone cells move in on top of that and start spreading out from that center point. That's how we get the primary ossification center. That's just the first place bone cells start to develop on this cartilaginous model that we lay down, made out of hyaline cartilage. We also find it in the nose and in the respiratory passageways. So all 3 of my cartilages stain a different color. In hyaline cartilage, this one comes out pink like a lot of my other tissues do. So when we're drawing hyaline, what we're going to end up with is this dark pink band, and then it's going to slowly start to get a little lighter as it works its way towards the middle. Now with all of my cartilage, they all, even though they're all different colors, they all have one thing in common, and that is a chondrocyte, a cartilage cell. Chondro for cartilage, cyte for cell. And these cells are almost egg-shaped or oval. So what we're going to do is do something like that, and then we'll get this nice, dark, bold nucleus right in the middle of it. You may also see where 2 of them are in the process of dividing, and so they'll end up something like that. That happens quite a bit. But all around, I've just kind of got these cartilage cells. Lots of room, lots of space. Notice they're not stacked on top of each other. Once we can recognize that oval shape with that nice dark nucleus and the room, we'll know that's a chondrocyte. Once we know it's a chondrocyte, then we just look at the color. And that's going to point us in the right direction. So in this case, if it's pink and we got the chondrocytes, it is hyaline cartilage. Elastic cartilage is a little bit different. This is actually my favorite tissue, my favorite one to ask about as well, because it's a little dark, it's a little twisted. I always thought if Tim Burton was a type of tissue, he would be elastic cartilage. It's kind of like my soul, just non-existent. No, that's not it. But elastic cartilage, flexible. We find it in our external ear. So when we bend our ear, that is from our elastic cartilage. And typically it stains in black or a purplish hue. And a lot of times it's a segue between those two colors. So we get, again, with my elastic cartilage, we get our chondrocytes. So there's a chondrocyte. We'll do another chondrocyte over here and another one. And this was very similar to bone in that we get that same kind of starburst pattern that we had, but in much less of a length to that pattern. So we're going all the way around again in blacks and purples, but a shorter length. And again, it's where these fibers start to cross each other that give elastic cartilage its strength and its resilience. So we're looking for the chondrocytes. We're looking for anything black and purple in that same sunburst pattern that we saw with bone. All right, our last type of cartilage to distinguish is fibrocartilage. So fibrocartilage, super tough, very strong. We use it as a shock absorber. We find it in things like our intervertebral discs, or your disc between your vertebra, in the pads of your knee that separate your tibia and your fibula, your tibia and your femur, and in our pelvic girdle. These are all weight-bearing joints. And so for all the weight-bearing joints that are going to take a little bit extra punishment, we're going to use fibrocartilage in there because it's nice and tough. So fibrocartilage is another one of those exceptions where that doesn't stain pink, which is nice because it helps it stand out. So we're going to get our cartilage cells in here, our chondrocytes. We'll do something along this line here. Boom, there, we got our chondrocytes. And this one actually turns out to be a bluish tone. So we're going to color all of this in shades of blue in the background around our chondrocytes. And a lot of times there'll be a little bit of red thrown in there as well, just from the staining pattern. So maybe we got a little bit of red down here. We'll do a little red around this particular chondrocyte. So fibrocartilage, it's blue on the stain, or at least on the slides that we have here at the school. So our last type of connective tissue specialized is blood. So blood has a fluid matrix called plasma. So let's re-hit that one more time. Bone had a solid matrix. Cartilage has a rigid matrix. And now blood has a fluid matrix, and we call that fluid matrix plasma. So a couple of things to understand about blood. We got red blood cells. Their job is to carry gases, both oxygen and carbon dioxide. They're carrying them both. White blood cells, they're there to defend. They're help to protect the body, fight off any intruders or anything that's going the wrong way. And then platelets. Platelets are involved in clotting, and we can help with vessel repair using this clotting factors and whatnot with our platelets. So that's kind of the makeup for blood. So overall, its job is to transport and to defend. Transport and defend is kind of the generic description for blood and its functions. So when we're drawing blood, we've got lots of little erythrocytes. There are lots of little red blood cells kind of scattered in here. They're really just stacked on top of each other all over the place. And then every so often, we are going to find a white blood cell. White blood cells we'll be able to note because they'll be purple, and they'll have a little shape to their nucleus here, probably. Do something along that line. And then more red blood cells. And we fill in the whole space. Blood is really one of the easiest ones to recognize. Everyone kind of knows what blood looks like or what blood should look like. And so once we start filling that in, it becomes super easy to identify. So let's know fluid matrix, plasma, transporting and defending, red blood cells, white blood cells, platelets, and what each of them do. Our third type of tissue is muscle tissue. Muscle tissue. So we have three types of muscle tissue to distinguish. First off, we have skeletal muscle, and we got smooth muscle, and we got cardiac muscle. So that's the first thing we really need to know. What are the three types of muscle tissue? Skeletal, smooth, and cardiac. So let's look at some of the interesting things about skeletal muscle. For one, skeletal muscle is a voluntary muscle, meaning I'm in control of my skeletal muscle. If I want to raise my arms, I'm doing it with skeletal muscle. If I want to wink, I'm doing it with skeletal muscle. I'm in control of it with my brain. I have complete control of my skeletal muscle. And it's the only type of muscle that is voluntary. So that's something that makes skeletal muscle stand out. It's the only one that's voluntary. It is also striated, meaning when we look at skeletal muscle under the microscope close up, we're going to have kind of this repeating pattern that forms in the fibers. So we'll have something along this line, pow, 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 and another one here. I'm not going to keep doing this for long. But we have this pattern that just repeats. That pattern is called a striation. And if you've ever thrown a steak on the grill or looked at a raw cut of meat, you can see there is a repeating pattern in that texture with skeletal muscle. Skeletal muscle is also multinucleated. So the big things we need to know about skeletal muscle, it's voluntary muscle, it is striated, it has that pattern, and it is multinucleated. So when we draw skeletal muscle, what we need to do is be able to repeat that pattern. So I've gone ahead and drawn in some kind of standard fibers that we're going to see. When we look at it under the microscope, what we're wanting to see is all along these fibers, we have this kind of repeating pattern that wraps around. These are my striations. This is one of the standout features of skeletal muscle. So something kind of along that line. It's very organized, very obvious to spot once you know what you're looking for. We have this repeating pattern, boom, 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 boom. Striations. Smooth muscle is our second type of muscle, and it is involuntary. I cannot control my smooth muscle with my brain. I can't be like carotid artery contract, vasoconstrict, go. I can't make it happen. My brain has no control of it. My brain's controlling my smooth muscle kind of in the background without me putting conscious thought into it. It is non-striated, so it does not have the same layout of its filaments. So we put the filaments down in a specific order. That's how we produce these striations because it's very organized. Smooth muscle is not. It's kind of randomly put down, so we don't have this repeating pattern, and it has a spindle-shaped nucleus. So all of that is good, important information to know for smooth muscle. It's kind of the opposite of skeletal muscle. Where skeletal is voluntary, this is involuntary. Skeletal muscle is striated, this is non-striated. Skeletal muscle has lots of nucleuses. This has one spindle-shaped nucleus in its muscle fiber. So skeletal muscle, because its filaments get laid down randomly, because it is non-striated, what we're going to see is part of the muscle maybe is running this direction. So we'll put all of these fibers running in this direction. And then the next set of muscle fibers is going to kind of run across in this direction. And then the next one will come down this direction. And what we end up producing is no pattern whatsoever because this is all just kind of completely randomized as it's laid down to give us that non-striation effect. So that's kind of what we want to see when we look through the microscope. When we notice all of these muscle fibers moving in different directions, we're going to think, that's smooth muscle because there's no pattern. Our last type of muscle is cardiac muscle. Cardiac muscle, of course, we're talking about the heart muscle. So we're going to find this in the heart. Well, it's involuntary, like my smooth muscle was, but it's striated. It has that repeating pattern like my skeletal muscle is. So a great test question would be something along the lines, which type of muscle is involuntary and striated? You're going to think, involuntary, that's smooth, striated, that's skeletal. No, it's cardiac muscle is the one that combines the two. So lots of good ways I could ask that stuff. And in cardiac muscle, we also have what's known as intercalated discs. So intercalated discs are a new type of intercellular junction. We looked at 3 at the very beginning of this PowerPoint. This is a 4th one that we only associate with cardiac tissue. So make that association, cardiac tissue, intercalated discs. And its layout, because it's striated, like our skeletal muscle, is very similar to where we're going to get kind of the same pattern almost cutting through like we have with skeletal muscle. But what we will notice with cardiac muscle is halfway or partway along, we're going to have these little connections. And these are my intercalated discs that are binding muscle fibers for my cardiac tissue. So that's what we really have to look for. We have to be able to spot these intercalated discs, but they're subtle. They're easy to miss. So make sure we know what we're looking for when we see it. We'll point that out on an actual slide, and hopefully that'll get a little bit easier. And that's it for muscle. We're going to save most of our muscle stuff for when we get to the muscle PowerPoint coming up here soon. But for now, skeletal muscle, smooth muscle, cardiac muscle, be able to distinguish all of those, one by sight, you got to know what they look like, or by description. Our last type of tissue is nervous tissue. And again, we've got a whole PowerPoint coming up at the end of the semester on the nervous system. So we're going to save a lot of it for then. For now, we're just getting some basics in. So our nervous tissue, one, we use it for sensory reception or for impulse conduction. So what this is really saying is sensory motor. So any impulses that are going to my brain and spinal cord are going to be sensory. I'm taking the information from the environment that my body's picking up, and I'm going to send it to my brain and spinal cord. Any impulses going away from my brain and spinal cord out to my muscles and or glands are going to be motor, because we're trying to have an effect, and that's going to be impulse conduction. So we have two types of cells in our nervous system. We got neurons. These are the functional cells. These are the ones that are transmitting those nerve impulses. This is the one everyone automatically thinks of when we say nervous tissue. But we also have what's known as neuroglial cells. So these are the supportive cells for the nervous system, and they really help bind the entire nervous system together. Neuroglial cells, super important. Don't forget about them. They are the support cells. So when we draw our nervous tissue, what we're going to see is basically a neuron is what we're going to see. So we're going to have a soma, which is the cell body of a neuron. Then we're going to have an axon, which is kind of the long tail-like feature on it. And then we've got our dendrites, which kind of branch out almost like a little hydra. So we're going to end up with something kind of along this line for our neuron or our nervous tissue. Another easy one to spot, nothing else quite looks like our nervous tissue. All right, so be able to distinguish all of the tissues, all the epithelial tissues, all the connective tissue, all the muscle tissue, and all the nervous tissue by sight and or description. The other thing I could ask is, where do we find it in the body? There were some tissues that were specific about where we find them. Let's make sure we know that information as well. All right, good luck.